Hello everybody and welcome back to the channel. So today I'm going to show you guys how to do real-time face detection with OpenCV and Python in under 5 minutes. So let's do this really quick. It's a neat little trick you can show your friends and family, and it's really simple using the Haarcascade model through OpenCV. So first thing we're going to want to do is install the OpenCV library, and we can do that by doing pip, going to our terminal and doing pip install OpenCV Python, and we hit enter. Now I've already installed it, that's why it says requirement already satisfied, but if you haven't, then go ahead and do that. The IDE I'm in right now is PyCharm. I'll leave a link to that in the description for you to download it. And let's just get right into it. So the first thing we're going to want to do is import this library, OpenCV, that we have just imported, and we can do that by doing import CV2. And then the next thing we're going to want to do is load in the Haarcascade model. And Haarcascade is just what OpenCV calls the model of face detection, so that we don't have to train and make a whole new machine learning model ourselves. So we'll call it face classifier. Face classifier equals CV2 dot cascade classifier, and this takes in a few parameters, or just one parameter actually. We're going to do CV2 dot data dot har cascades plus, and then we want the actual XML file, which is going to be Haarcascade. Make sure you're spelling this right, exactly how I have it. Frontal face underscore default dot XML. Perfect. Okay, so now we've imported our OpenCV library and the model itself. And the next thing we're going to want to do is access our computer's webcam. So we can do that by simply doing video underscore capture equals CV2 dot video capture in parentheses 0. And let me add some new lines in here so that it's a little more organized. Perfect. And now we want to identify faces in our video stream, right? So let's make a little function. We can call it detect face, and we'll pass video. We'll call it vid. So the first thing we're going to want to do is, our video is a set of streaming images, right? So for each frame or image in our real-time video, we're going to convert it to grayscale, so black and white, so that our computer can run our program a little more efficiently. So let's do that with gray underscore image equals CV2 dot convert color, and we'll do video, comma, and then we want to do from red, green, blue to grayscale. So we're going to do CV2 dot BGR to gray, just like this. And if that doesn't make sense, it's just because our original video that our computer records is in color, red, green, blue, and we want it to convert to black and white. Next, we're going to get our faces from our model, so face classifier dot detect multi-scale, and we're going to use gray image 1.15. This is just scaling our image, and we'll say min size equals 40, 40. So this is what actually is going to detect in our image or frame our face. And now let's we want to draw a rectangle around our face on the real-time video to signify that we have detected the face. So let's do that with for x, y, as x and y positions of our face as like a coordinate grid on the real-time thing, and then width, comma, height in faces. We want to draw a rectangle, so we'll do cv2.rectangle. And then we want to first pass vid, and then for coordinates, we'll do x comma y. That's the x and y coordinates of the face. And then we're going to add the width and the height of our face to create that box. So we'll do x plus width, comma, in the parentheses, y plus h. Then outside that comma, we're going to do 0, 255, 0. That's going to make it a green box. If you wanted to make it a red box, you would make this number 255. You want to make it a blue box, make this one 255. You could also make it a white box, a black box, however you want it. But I'm going to do green for this video. That's just RGB. So the first value is red, second value green, third value is blue. So since it's all green, it's going to be a green box. And finally, we'll do 4. Okay, perfect. And finally, what we want to do is return the face that we've detected, or faces if there's multiple faces in the video stream. So we'll return faces. Okay. Now the last thing we're going to want to do is create a loop to use this function. So let's do while true. And then we'll do result, comma, video underscore frame equals video underscore capture. So that's our video capture dot read. And now we want, so we'll do if result is false, break. So here we're getting our video capture, and then we're reading our video from the source. And if we can't, then we're just going to break our program and end the loop. Then we're going to do faces equals, and then we're going to use our detect face. And we're going to pass our video frame into that function because that's the video that we want to detect from. And finally, we're going to show our video on the screen. We're doing cv2.imShow, which is image show basically. And then we'll say face detection project. That's going to be the header of our window. So that's what's going to be at the top of our window. And we'll do video frame. Perfect. And the last thing, to quit our program when we want to close out the window of our face, we can just do, we'll say if cv2.waitKey 1, and we'll say q for quit, so 0xff equals ord, and we're going to do q. Then we also want to break the loop and end the program. And at the end of our program, we want to release the video capture and destroy all the windows. There we go. Perfect. So this should work. Let's hit run, and our face should pop up. Perfect. So you can see my face as I move it around. There's perfect tracking, and that's it. And now I'm going to hit the Q button, and we are done. So that's it for this video. Hopefully that helped, and thank you for watching. If you have any questions, please leave them in the comments down below. Thank you.